problem 8.8-154 from section 8.3.2. The graph of p of x equals x to the third plus 4x squared plus x minus 26 is shown at the right. Use the graph to find one solution to p of x equals 0, then use the remainder theorem to find a factor of p of x. Read about the remainder theorem in the math notes box in this lesson. So what we're basically saying is, when does y equal 0? When is the height? When is there a point that crosses when y is worth 0? Right here. That's at positive 2. So they're saying if we plugged in 2 into our equation, the cubic, we would get out a 0, which means there's no remainder, which means it's a factor. So I need to write this as a factored form would be x minus 2. Remember, it's the opposite, because if I set that equal to 0, right, just like we set that equal to 0, I need to get out x equals positive 2. That's why it's the opposite. So here's one of our factors. Now to find the other factor and then to find the roots, we're going to divide the big cubic by the x minus 2 factor. And so we're going to do that with our rectangle. So x minus 2. And the cubic is x to the third plus 4x squared plus x minus 26. Again, you don't have to write that down there if that confuses you at all. Okay. So my first factor needs to be x to the third, because that's the first term in my answer. So this needs to be x squared. If I multiply the things together now, I have negative 2x squared. Alright, now in the next diagonal needs to add to be positive 4x squared. So in order to make that happen, this part right here needs to be positive 6x squared. Okay? So this would need to be 6x. In order for that to multiply correctly, this would be negative 12x squared. Okay? So next corner here is I need this to be, add to be a, oops, sorry, this should not be a square. Let me see if I can just, yeah, there we go. So that should just be a regular x. So these two things need to add to be positive x. So this needs to be 13x. So in order for that to happen, this would need to be 13. 13 times negative 2 is negative 26. So that's good. I didn't need this last box. That's fine. But this is the final thing, which means there is no remainder, which means that's a factor. So I'm going to write x minus 2. If I multiplied that by the top of our rectangle, x squared plus 6x plus 13, I would end up getting this cubic. I'm just working backwards. Okay. So now I have this quantity squared, which I need to find the zeros. Now in the problem it says factors. It says determine all the real and complex factors of p of x. Okay. So I want to find the zeros. So I need to, if I solve this one and set this equal to 0, that one's pretty easy. But if I set this one equal to 0, it's not going to turn out nicely. And we can see that from the graph. I know it does not cross again, so it's going to be an imaginary solution right around there. Okay? So let's figure out what that is using the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So I have x equals negative 6 plus or minus the square root of 36 minus 36 minus that quantity would be 52, which is going to end up giving me negative 16 under here divided by 2. Alright, so that it immediately tells me that's a good thing. I'm not supposed to have a real solution. I'm supposed to have complex solutions. So that's good. So I have x equals negative 6 plus or minus the square root of 16 is 4, and the square root of negative 1, we call it I. That divided by 2, I can simplify that, divide each of those by 2. So I have my two complex solutions are negative 3 plus or minus 2i. And my real solution was x equals 2. Alright, so those are the ones that we get there. Make sure that you do get a complex solution because it only crosses the x-axis really one time. So where it dips down here, that's the other one. And also, the reason, the reason that it's below the x-axis, if we got our answer, it was negative 3 plus or minus 2i. If it was positive 3 plus or minus 2i, we would have a little dip above the x-axis, okay? So that's what that means, why it's below versus above for the imaginary root. So we're looking at the graph to find one of the zeros, and then we divided the cubic by that to find the other factor, and then solve that for x.